Welcome. In this video, we're going to talk about writing some code to get our hacked RC car to do one of the first things that we're going to have it do, which is just kind of run through a fixed routine, go forward, turn left, turn right, stop, without any kind of sensors informing what it should do. This is a good kind of compartmentalized step before it gets more complicated. One of the main goals of this activity here, this assignment, is to learn how to create your own functions, so that we're extending the library of kind of predefined terms that we can use, like pin mode and stuff, to make our actual code a little bit easier to look at and read. So what I've set up here is I just opened up a new Arduino sketch in the IDE, or Integrated Development Environment, and added a few comments about what I want to put in here. So in addition to the required setup and void loop definitions, I made a note here that I want to define the 4 pins that are going to control the relay module we're using. With 4 single pin double throw relays, we can control 2 motors and make them go forwards, backwards, and stop. So that allows us to get all control of the 2 motors on the RC car. In the setup, we'll have to define the pins as outputs. And then in the loop is where we can make our whole routine. If we wanted to go, forward for 5 seconds and then turn left for 2 seconds and then stop, that'll be in this area. And then down below is where we're going to see something kind of new. How do we make those commands a little bit easier? How do we make stop, go forward, turn left, be things that we can just say with one line instead of a whole bunch of lines of code? For your assignment, just a preview, you're going to want to make sure that you kind of follow along with the video, and I'll get you started with a few of those functions, but then your job will be to finish it up. This code, make sure you save it on your school laptop so that you have it to actually use on the RC car when we're at school. So defining the 4 pins that we're going to use here, we did practice this a little bit already. Whenever you define a variable, you always have to say what type of variable it is. So the pins are all integers. They're just whole numbers, 0, 1, 2, 3, 4, 5. You have to give that variable a name. So I'm going to try to use some kind of consistent naming here that makes sense. I'm going to call it motor 1A, because each motor is going to have 2 relays that controls it. That makes a full H bridge for us. So we'll have motor 1A, motor 1B, motor 2A, and motor 2B. And then the next thing is to assign some value to that. So this value will actually be the pin, the GPIO pin, general purpose input output pin, on the Arduino that we're going to use. I'm just going to start with 5 and go upwards from there. But the nice thing about using these variable names is we can always go back and reassign this to another number, and we only have to change that one line. So I'll do the next parts kind of quickly. Okay, and there we've defined our 4 pins that we're going to use on the Arduino to control the relay, and giving them some names that we can use in our code, which hopefully makes a little bit of sense. And I'll point out I'm using lower camel case with the variable names. Always make your first letter lowercase, have no spaces, but any new words, always uppercase those. In the void setup, these lines are going to look pretty similar, so we can save some time by just kind of copying and pasting. We'll use the pin mode function, and pin mode takes 2 inputs, of course, the pin that we want to define. So I'll start with motor 1A and the mode it's in, whether an input or output. In this case, it's going to be output. We'll send electricity out on that pin to control the relay. So we need 4 very similar looking things there. The only thing that's going to change is some of the names here. So motor 1A, motor 1B, motor 2A, and motor 2B. All right, that looks good. With the loop area, I'm going to start showing you how to do this the wrong way. It's kind of the brute force method before we go ahead and then start defining the functions, which will make this look a whole lot better. So if I want this to go forward, for 2 seconds. Then the code might look something like this. I have to make sure that the 2 relays that are controlling the steering aren't powered, right? So they're kind of in their default state. So I don't want them, one of the relays for the steering motor to be high because then it would go right, or the other one to be high because then it would go left. If they're both in their normal state, then that's going to make the car just go forward. All right, so go straight. So I'm going to explicitly state that and use the digital right function to make sure that that pair of relays is in its unpowered state. So I'm just going to pick, let's say that motor 1 is for the steering, motor 2 is for the going forwards and backwards. I'll actually add that in my comments up here so I don't forget. Motor 1 for steering, motor 2 for driving. Okay, so the relay modules that we're using, I'm pretty sure the default setting is if the pin is written high. All right, so that means that 5 volts is coming out of that pin, and when the relay feels that, it's going to keep that relay so that the common is connected to the normally closed. It's basically like the default setting. So digital right motor 1A high. We'll kind of keep it in that default state. I put a space here, but remember, Arduino is not white space sensitive, so I can leave that. And I'm just going to ensure that the other relay that's part of the steering is also written high, right? So that makes sure that no current flows through the steering motor. We want it to go forward, straight forward. So my other 2 pins, motor 2A and 2B, there's a little typo there I need to correct. One of those needs to be high and one needs to be low. I'm not sure which one it is, and we're going to do a little trial and error when we actually construct this to figure out what the right combination is. If we run this and it goes backwards instead of forwards, we'll know we did it wrong. So let's just leave the A high, and we'll make the B low. All right, so hopefully that makes it go forward, but again, we'll have to check for sure. And if I want it to keep these settings on the relays so that it actually does this for 2 seconds, we do need to add a delay. Remember, delay takes an input that is in milliseconds. So I'm going to add 2000. Wow, so just to make it go forward for 2 seconds actually took 1, 2, 3, 4, 5 lines of code. If we're going to have this car run through some kind of maze, you can see that this loop section is going to end up looking really, really long. Every time it makes a change, I have to rewrite what all 4 of the motors are doing. So this is why having functions, defining your own functions, can save us some work. So let's take a look at how we do that down below here. The area that you define your own functions needs to be outside of the curly brackets for the setup or loop function. You can either define them above or below, kind of at the end of the code or the start. And the most common convention is to do it at the bottom. So that might seem counterintuitive because it looks like we read the code from the top to the bottom. But when our integrated development environment compiles our code, it actually reads the whole thing, including what's at the bottom. So it's going to know what these functions mean when it then gets powered up and actually tries to run the code. So don't worry about the kind of weird ordering here. One other thing too I'll point out about defining your own functions is that setup and loop are actually being defined. This format that we see in the setup and loop functions is basically the same format we're going to use. the first word here is what does the function, what type of variable does the function return after it's done doing its job? It could be a Boolean value, something that's either true or false. It could be an integer value, some kind of whole number. It could be a float variable. That means it's got a decimal point. Or if it doesn't return anything at all, it just does the commands that are inside the function, then we say void. It doesn't return anything at all. And that's going to be true for us with our car here as well, our robot. We just want it to do the operation inside the function, but not give us back some kind of data. So we'll say void there. We got to give it a special name that isn't already part of the Arduino library. So something here, I'll try calling this go forward using lower camel case. Cool, and that didn't change color as I typed it out, so that indicates to me that that's a free combination of letters I can use to name this function. Next, opening and closing set of parentheses, and those parentheses are going to include any required inputs to make the function work. We're actually going to use something there, but I'm going to leave it blank for the moment. Next, a opening and closing curly bracket, and what goes between those curly brackets is everything that happens when the go forward function is called. And where is it going to be called? Well, we can call it up in the setup or in the loop. Those are the two places we can use this new function that we're defining. Just like we could call digital write in loop, we'll be able to call go forward in loop. Ended up with an extra curly bracket there. Okay, so go forward is going to be all this stuff up here, right? We already defined what go forward means. We make sure that the steering motors are not powered, so it's just going straight, and that the drive motors are in some kind of combination where one is high, one is low, so current flows through it. So I'm just going to cut this out of the loop area and put it in my go forward area. I'm going to add an indent here just so the white space looks nice, and I can kind of see that all these things are inside this function. That's why the indentation helps. Awesome. So now I could, in my loop area, just say go forward like that. And it will do all of the commands here, but I'm just writing this one statement there instead, which is a lot cleaner to do. The last thing that we're going to add to our function here, though, is some way to adjust how long we go forward for. Basically, calling this function as we've written it so far just sets the motors in the right power mode. How long it stays that way is being defined by this delay function afterwards. So let's make that part of the go forward function, and then we can adjust that value a little bit easier. And it will reduce these two lines down to one line. So back down here where we're defining go forward, the parentheses that are behind the name, I said that's where we can define any required inputs that we want go forward to do. What I would like is to have go forward take one numerical input, an integer to be specific, that is how long it goes forward for. So let's, in the parenthesis here, you don't actually like put in that number. You put in the name of the variable that you're going to use to define that quantity and what type of variable it is. So I already said it's an integer. So I type int space. And really I can give this any name right now, but I'll try to keep it descriptive. I'll call it like go time, all right? And that doesn't change color, so I know that's a free word I could use there. This will actually be a number that we put in up here, like 2000, right? So 2 seconds, 2000 milliseconds. But here's we're defining it. We're going to use this general variable name. Right, so what are we going to do with this input, this integer that this takes? Well, that is the amount of time it needs to keep this state held for. So one more part to our go forward function is let's add that delay. And how long do we delay for? We delay for the go time. Whatever the user puts in, will be that quantity. Cool. So now I can remove the delay from our loop area. And this is doing everything we had before, going forward for 2 seconds by calling this one line. This is super nice because I can reuse it over and over and over again. Perhaps I want to go forward, stop, turn to the left, stop, and then go forward again. Well, when I need that go forward again, I can just recall this and use this an additional time. I can even make it a different amount of time. Maybe I only want it to go forward for half a second the next time I call it. Okay, so this basic format here is the most critical part of what we just did. The exact naming and the name of the function and the name of this variable for the amount of time it does that function for, not super critical. But you're going to want to repeat this a number of times. What I want you to do for your assignment is create an additional function. We have go forward, so we should make go backwards. We'll need turn left. We'll need turn right. And this is often overlooked. We'll need something that brings it to a full stop. So something that will like set everything back to their default closed states, so no current is flowing through either motor. All right, go forward, go backwards, turn left, turn right, full stop. Awesome. So combining these with their different time inputs, we could basically get the car to go through a really, well-determined fixed routine. It might take some trial and error to get the timings right of how long we need to go in each direction. But this is a critical first step in order to make things a little bit more complicated. Just to get you started, so go backwards. You already have most of the work done. I would take your go forward, copy it, paste it down below, and then just change a few critical things. Go forward can become go backwards. We still don't want to have it turning any direction, so I'll keep motor 1 set to high, both A and B. And we're just going to switch around motor 2. So what was high will be low. What was low will be high. That was an easy one. And you'll repeat that, making some slight changes for turn left, turn right, and full stop. Have that done for next time, and we should be able to basically plug this in and see it work on your actual RC car within maybe a class period or two. Don't forget office hours on Wednesday. If you have any questions, email me if you can't reach me then. Good luck.